Hi guys, Nick Howell here, the data center dude from NetApp, Virtualization Solutions Architect. Today we're going to talk about policy-based management and VVols with NetApp. Just a quick disclaimer for you, some of the things that we're going to talk about today are still currently in beta or RC phases, so just to let you know, these are subject to change as we go through. First of all, let's talk about policy-based management. Feedback. Good. First of all, let's talk about policy-based management. What is that? It's a standardized set of best practices. From the NetApp side, we refer to them as storage capability profiles. On the VMware side, you're going to hear them referred to as VM storage policies. This is a way for you to predefine settings for all VM and data store related objects as you configure your data center. But what we have to look at is how has this mentality changed operations? Instead of doing everything discreetly, now we're doing everything in an automated setup. To do that, let's take a trip down memory lane. For those of the OGs, you'll appreciate the history. For those of you that are kind of newer to the industry, you might appreciate the history lesson here. So if we go back to the late 90s, all the way through up to where virtualization really kicked in, systems admins were kind of servants to application owners. They would basically be reactive to anytime a DBA needed more storage or he needed more horsepower. The exchange guy needs another server or another database. This involved many, many repeated tasks, this heavily leveraged scripting, and any admin worth their salt knew how to write VB scripts because of these things. If we fast forward to the late 2000s up until 2012 or so, we kind of got more into virtualization, right? Consolidation, shared storage became king because we needed to do vMotion, storage vMotion, things like that. And the biggest thing is we got the ownership back, right? We weren't servants anymore. We got to do all of these things. But with great power comes great responsibility, and now we had to do everything. So 2012 and beyond, from my perspective, this was the rise of the generalist. He's known by many names. He's a data center engineer, he's a cloud specialist, he's an infrastructure specialist, or even a virtualization solutions architect, which myself. The problem with this is that there was just too much config, right? This brings on the world of automation. Too much config going on, too many little nerd knobs to twist every now and then, every time you configure something. We needed a way to automatically select settings, automate repeatable tasks, and I believe that this brought forth the rise of certain automation platforms. We've seen PowerShell and PowerCLI really become the king in things. VCO, VCAC, and now called vRealize, and even NetApp's own workflow automation has really taken hold. Enter the new plugin called the VASA provider. So a lot of people don't really know what this is yet. So VASA who? It's vSphere APIs for storage awareness. This is basically a set of vSphere APIs that was introduced in vSphere 5.0, and it introduces the concepts of standardization and compliance into your vSphere environment. So what do things look like without this? Well, it's what we have today, really. It's native abstraction of resources, such as Datastores, that are complexities below that on the storage arrays. It was a really good idea coming in, but it had blowback, right? We had to deal with a lot of these things that we were talking about before when everybody became generalists. A lot of things to configure, a lot of things to go through. Virtualization introduced a lot of this new complexity that didn't exist before. So while it did make a lot of things simpler, the blowback was that it brought some new things to the table. What things look like with VASA is it gives us the ability to uplink these features that your storage arrays have directly into vCenter. Now, instead of just an abstracted data store, vCenter has the ability to understand all of the features that are specific to each of your storage arrays. For NetApp's examples, snap mirror, deduplication, flex clones, all those sorts of things can be leveraged now directly by VM admins. These also can be bundled or packaged into what we call profiles or storage capability profiles that we'll get to in just a second. These profiles, they're the programmatic equivalent of these nerd knobs. You set them once and you can apply that profile to any construct within the data center. It introduces a whole new level of simplicity. So last year, NetApp introduced their VASA provider. Today, we have a brand new one. It's currently in beta. It's available for clustered data on tap, and it does the same thing. It advertises all of these storage features. There's a very long list of them, including replication, data protection, storage efficiencies, disk types, HA or not. It deploys as an OVF appliance in your vCenter and directly integrates with our top plugin, the VSC, or Virtual Storage Console. As you can see, it's a one page of setup. You just give it a name, an IP address, subnet mask, and a gateway, and it deploys itself automatically for you. If we take a look at policy-based management and VVols architecture, in a sense, we'll get to VVols specifically in just a moment. let's take a look. We have the VSC in place that uses vSphere APIs to communicate with vCenter, but it also uses the ZAPIs to communicate with the clustered ONTAP storage. We then introduced the VASA provider. VASA provider is an out-of-band management technique that communicates all of these storage functionalities back and forth between vCenter and ESX hosts, as well as your storage controllers. Now we're connecting all the way through. We don't just have one middleman, the VSC, that's calling everything. We're now able to leverage the VASA provider to take advantage of all these things. So now you have someone sitting at the vSphere web client that all they need is access to vCenter, and they can leverage, with these plugins, they can leverage these functionalities. So what are storage capability profiles? They're just, examples are we deliver a gold, silver, and bronze template. You can create as many of these as you like. They include all of the features that that are specific to your storage arrays, such as snap mirror, dedupe, disk types, all those sorts of things. And again, they're programmatic storage efficiencies that you can apply to any vSphere object across the board, whether it's a virtual machine or a data store. Traditional data stores, even though we simplified things with the virtual storage console for data store provisioning, there was still some things in tunables that were still required manual input that we had to put in. So the VASA provider opened up the door for us to continue to automate this process, set it one time, forget it, and just apply a profile going forward. These decision points can still be automated further, and we have with the VASA provider. So the VSC is the fundamental part, it's the platform. The VP brings further automation in as you go forward. Taking it to the next level, we're now integrating at the VM storage policies. So one of the new things that were introduced in the latest versions of vCenter is the idea of creating VM storage policies, or VM granular profiles that will set up any clone going forward. We directly integrate into this with our VASA provider. You can create a VM storage policy that pulls in storage array features from the VASA provider. You can choose a preset profile name, or you can choose any of the discrete functionalities that the storage array presents as well. The VASA provider also introduces a way to monitor compliance and correct that compliance if you want to. Here we have on the screen a listing of all of the data stores that are in our data center. And over on the right, you'll see in the blue box, we have non-compliance reason. This data store is out of compliance because someone, likely a storage admin, turned deduplication off on a volume that was one of your data stores in your vCenter. So we report that, we alert that, you'll receive a vCenter alert, and you can right-click on this and correct that action as well. So why VASA? Why now? It's my opinion that the infrastructure and virtualization era is over, and we're beginning to move on into these automation and cloud platforms. We have multiple clouds to deal with. Each of these clouds have their own unique, discrete capabilities. We're dealing with enterprise private clouds. We've got public clouds, such as Amazon, Azure, VCHS, or vCloud Air, I should say. Hybrid offerings as well coming through, such as OpenStack. Policies are necessary to, I think, re-simplify data center operations. Not undo all the progress we've made for the last few years, but take it back to when things were a little bit simpler. The cool thing is that this also sets up the foundation for VVols. VVols are hot and heavy right now. It's what everybody wants to talk about. It is the hot topic that everybody in our booth is asking us about. What is a VVol? It's been known by many names over the last 4 years. This was a design spec where NetApp, HDS, and Dell EqualLogic got together and said, we need a better way to do storage in VMware. It's the biggest change in virtual storage since VMFS, in my opinion. So VM volume, virtual volume, vDisk, we're just going to call them VVols. What these are is the storage object components of a VM. You're going to have multiple different kinds. You're going to have virtual disks, which will be kind of like your VMDKs, but in addition, you'll have config files, memory and swap files, as well as any snapshots that you take. How does this work with the different protocols? So for block protocols, all VVols are actually LUNs on a NetApp storage array. Some VVols also contain a small VMFS file, or what's known as a config VVol. You used to know this as your VMX file in your VM layouts. For NFS, we do, everything is files, right? I'm a huge NFS fanboy, if anybody that doesn't know. I love doing this. So everything is just files and directories, as always. Your VMDK, swap, etc. will just be files, and again, the VMX file will be a special directory that will house that information for you. The other part of VVols that's necessary to understand is protocol endpoints. It's different for the way that SAN and NAS work, so we're going to go over each of them here. LUN VVols are mapped like other LUNs. So you're going to have a small, what we call a proxy LUN, that's going to live inside the same master LUN. It's about 4 megs in size, it's not very big, but again, it's just to house a little bit of that configuration. There's no path and no LUN count consumption to deal with here, as far as those are concerned. For NFS, vVols are just path export paths, same way they always have for data stores, and same way they've always been for any kind of exports out of NetApp storage. And you don't need an NFS mount for each individual volume. vVols are accessed through protocol endpoints. This is for whether you're using SAN or NAS, it doesn't matter. We treat it the same way. A vVol is a vVol is a vVol. It's only the way that it connects on the back end, which the VM admin really doesn't need to care about, frankly. Really small LUNs, again, 4 megs for block protocols. NFS mounts at the root volume of what we call the storage VM, which is an abstracted storage controller on top of clustered data ONTAP. And the protocol endpoints are created when you install that VASA provider. So when you create your first vVol data store container, it creates that first protocol endpoint for you based on how you decide to connect to it. And when a vVol is actually accessed, you'll get a bind operation. So you'll see differences in vVols where they're bound or unbound. When you fire up a virtual machine that has vVols configured in it, you're going to see a bind operation happen. And what it does is it connects that protocol endpoint it locks in a link from that protocol endpoint to the storage VM that's on that clustered ONTAP node. So let's do a comparison, SAN versus NAS, right? This religious war has somewhat fired up again recently, but I want to squash any reasons of that. At NetApp, we're unique, I think, that we have, we just don't care. It's whatever protocol you want to pick, and vVols really perpetuates that even further. As far as LUNs are concerned, if you're doing block or SAN, it's 1 per FlexVol. You need 1 protocol endpoint per FlexVol. That's mapped to a LUN ID starting at 300. So this is a little bit technical. If you're NetApp customers and you're doing SAN, you probably know exactly what I'm doing. If not, sorry. Multipathing certainly applies here, right? vVols continues to take advantage of any multipathing that you're used to with regards to ALUA and any round-robin PSP policies that you've used in the past. If there isn't a LIF on the storage VM of a node, the PE is not going to get created. So one of the prerequisites that you need to know if you're getting into vVols is that you need to pre-create your LIFs on your storage VM that you intend to host those vVol data stores on. The protocol endpoint is created in the volume for each container. And again, it's a 1-to-1 relationship, 1 protocol endpoint per FlexVol. For NAS, everything just continues to be easy, like it always has been. One protocol endpoint per LIF per storage VM is really the main thing you need to know when you start sizing. Protocol endpoint determines the direct path to bind each virtual volume to. And that's it. NFS continues to be awesome. NAS for life, right? In summary, policies set default best practices. Policy-based management is the way of the future, in my opinion, and it's going to make things easy again. We're tired of configuring in structure, we're tired of tunables and nerd knobs. We need automation and we need orchestration to make these things really simple. One other thing I want to call out is that don't take intelligent placement for granted. When you're creating these VMs and you have these predefined policies and profiles in place, you create a virtual machine through an automation engine or even manually, and all you have to do is pick a policy, and that intelligent placement is going to go right there, and it's going to put the VM in any of the data stores that match, or alert you if you don't have any that match what you've selected. The principles of policy-based management that we talked about before we got into vVols really sets up a strong foundation because everything carries forward. Everything that you're doing that is available today in vSphere 5.5 and NetApp VASA and VSC policy-based setup is a great transition. It's going to carry forward into vVols in the future. Social media, you can find me over at datacenterdude.com. I've got a lot of posts coming on vVols, protocol endpoints, LUNs, NAS, all kinds of good stuff around these topics. You can find me at DataCenterDude on Twitter. And come check us out at the NetApp Communities podcast. You can find us on the iTunes Store, Android, or Stitcher. Thank you very much.